Here's an object. I'd like to change its temperature. So this object has some mass m and some initial temperature T naught, and I want to make its T naught greater. So I want to change its temperature in some way. So the way that we do that is by adding heat. I move heat into it. But what is heat? Heat is energy that flows between, sorry, not from, between objects of different temperatures. Of different temperatures. The symbol for heat is Q. So if I want to make this hotter, I need to put it next to something that has a higher temperature. So let's take this hot gas on the end of this match here. So I'm going to lay this here. This has some hot temperature. Energy is going to flow from there into there. So there's my heat that flows in there. How can I figure out what this change in temperature is going to be? So the change in temperature is going to depend on a couple things. It's going to depend on how much heat moves across. More heat, more heat, more temperature change. More mass, less temperature change. As there's more mass here, then it's harder to change its temperature. And then it's going to depend on the type of material. This is called the specific heat. Specific heat capacity. Get that up in the wrong spot. Specific heat capacity. It's very much a thermal inertia. So this depends on what this is made of. If you rearrange this around, you get what you are very specific. You get what you have seen before, where Q equals mc delta T. So let's take this cup of coffee. So it's at this cup of coffee, my fancy cup. So I have 300 grams of coffee. It's originally at 15 degrees. That's my T initial. And I have, I want to heat it up to 90 degrees because it's cold. How much heat do I need to move into it? Well, so here's my mass. I have 300 grams. That needs to be 0.3 kilograms. So must be kilograms. 0.3. Heat. This is coffee. What coffee is pretty much water. And the C of water is 4186 joules per kilogram Kelvin. And remember, so this is in C and this is in C, but a Kelvin is the same. A Kelvin is the same size as a Celsius degree. So this turns into CO. Whoops. 4186. And now 90 minus 15. I did this on my calculator. So I end up with something that looks like this. So I end up with 94,185. Heat is energy. Energy is measured in joules. So 94,185 joules, which seems like a lot, and it kind of is, but a joule is not a lot of energy. What about calories or BTUs? Those are old British units that we don't use anymore.